Hello everyone. Today I'm going to introduce you to the fundamentals of machine learning. In the last lecture, I told you that machine learning is one of the backbones of data science. So we want to see the whole view of machine learning, what it entails. And we're going to see what we need to know as far back as machine learning is concerned. Okay, let's follow this outline. I'm going to tell you about uh, how machine learning can be defined. What is machine learning? You must have been conversant with it. But then we're going to see the types of machine learning and the key components of machine learning, applications of machine learning, challenges, and tools and libraries you need to know in machine learning, and some future trends in machine learning. Now let's get started. As we start, I want you to know that in all that we are going to be teaching, we are trying to put it as simple as possible. And that is motivated by this quote from Albert Einstein, which says everything should be made as simple as possible, but not simpler. So all the definitions I'm going to be giving you, all the explanations I'm going to be giving you will be in the most simplest form as we go along. Okay? Now, machine learning is a subset of artificial intelligence. Artificial intelligence is a broader field that encompasses machine learning and deep learning. So machine learning is a subset of artificial intelligence that empowers computers to learn and make predictions or decisions from data without explicit human programming. It involves the development of algorithms that iteratively analyze data and identify patterns in them and refine their models. These algorithms are trained using vast data sets to recognize relationships and trends, which enables systems to make predictions and classify information or take actions based on new, unseen data. Now, if you look at this diagram, you'll see that machine learning has relevance in many fields, be it game theory, control theory, information theory, philosophy, psychology, neurophysiology, optimization, statistical mechanics, data mining, probability and statistics, biological evolution, computational complexity theory, and so on and so forth. Machine learning has gained wide usability in so many fields of human endeavor. And so that is why it is important for you to know a lot about machine learning as a potential data scientist. Now, before we proceed, you must have seen this diagram in so many places. This is a diagram that depicts the relationship between artificial intelligence, machine learning, and deep learning. You see, machine learning and artificial intelligence, and deep learning. Deep learning is embedded in machine learning, whereas both of them are embedded in artificial intelligence. So machine learning basically creates algorithms that can learn from data, make decisions based on patterns observed in the data, and require human intervention only when the decision is incorrect, right? So we're going to consider mainly machine learning today and some deep learning models. Okay, now what are the basic types of machine learning? When you talk of machine learning, what are the classifications of machine learning? We have supervised learning, where models learn from data to make predictions or classification. We have unsupervised learning, which discovers hidden patterns within unlabeled data and useful in clustering and dimensionality reduction. We have reinforcement learning, which teaches agents to make decisions by trial and error. It is valuable in autonomous systems. And we have semi-supervised learning, which combines labeled and unlabeled data together. We have transfer learning, which uses knowledge from one task to aid another. And then we have also self-supervised learning, which generates labels from data itself. Now we're going to try to consider each of these one by one as we proceed. Now, the major ones, the most popular types of machine learning are these three: supervised learning, unsupervised learning, and reinforcement learning, right? And we're going to look at what each of them entails as we move on. Now, let's look at supervised learning. Supervised machine learning is a type of machine learning where an algorithm learns to make predictions or classification by training on a label data. By label data, we mean whenever you are confronted with any data set that has both target and input, it has target and explanatory variables. That is a supervised machine learning. You know, when you have y and x, what we call y and x, that y is a target. That is supervised learning. Whereas you are using the x to control, or to predict the y, in a controlled manner. That is supervised machine learning. In supervised learning, the data set includes both input data features and corresponding target output labels or values. Now, the primary objective of these types of learning is to learn a mapping. It's a mapping from the input to the target output, which allow you to make accurate predictions or classifications on new, unseen data. So you should, at the end of this course, you'll be able to separate or distinguish between supervised and unsupervised learning, right? Now, let me look at some characteristics of supervised learning. The first characteristic is label data. Data where we have both input and output labels. Those both of them are known. Not data set where you don't know what is the target variable or what is the dependent variable, right? Okay, so you see that is supervised learning. That's one major attribute of supervised learning. And another one is prediction or classification. The one major aim of supervised learning is prediction. It's used for prediction or classification. Supervised learning is used for tasks like predicting numerical values. When the target variable is a purely numerical value, then that is a regression problem. But when the target variable is a categorical variable, then that is a classification problem. Okay, so that is one thing you need to know in supervised learning. These are features of supervised learning. You may be asked, how can you distinguish between a regression problem or a classification problem? The answer is in the target variable. If the target variable is a numerical variable, then you are talking of a regression problem. You can only use regression models or algorithms, right? But if your target variable is a categorical variable, then you have to use classification algorithms, because that is a classification problem, right? So you must know. I spend time on this because that is a very good point to identify. Now, there is also feedback mechanism. The algorithm receives feedback on its predictions, and it allows it to adjust its internal parameters and improves its performance over time. Now, there are some popular algorithms that are used for supervised learning. They include algorithms like logistic regression, linear regression, support vector machine, decision trees, random forest, naive Bayes, and neural network. The neural network is a deep learning method. Okay. Now, the choice of an algorithm depends mainly on the specific problem and the nature of the data, like I've said. That is, if your data, the target variable is a numerical variable, you use a regression variable. You use a regression model. Or if your your target variable is categorical, then you talk of classification algorithms. And some of these algorithms, some of these models can do both classification and regression. For instance, in all of these now, it is only logistic regression that cannot be used for regression problem. All the others here, they can be used for both. They can be used for both classification and regression. Support vector can be used for classification and regression. Decision tree can be used for classification and regression. Random forest also. Naive Bayes also. A neural network. But this one is for purely regression problem, and logistic regression is for purely classification problem. The other ones are for both. Now, supervised learning is a fundamental approach in machine learning, and it forms the basis for many real-world applications. Now, let's say something about unsupervised machine learning. When we talk of unsupervised machine learning, this is a category of machine learning where the algorithms are, are used to analyze and find patterns or structures within unlabeled data. When we say unlabeled data, it means that unlike supervised learning, unsupervised learning deal with data that lacks predefined target labels or values. The values are not labeled. I mean, the target, there's no target, there's no the data, no variable in the data that is saying this is the dependent variable, right? Instead, the goal is to discover inherent structures and relationships or groupings within the data. Now, unsupervised learning is often used for data exploration, dimensionality reduction, and clustering. So whenever you are doing any task like data exploration, like dimensionality reduction, principal component analysis, factor analysis, and so on and so forth, and clustering, k-means clustering, hierarchical clustering, these are unsupervised learning tasks. Let's see some characteristics of this unsupervised learning. It uses unlabeled data. It uses unlabeled data. The data set consists of raw data with no association, target, values, or labels. Then exploratory analysis is used, unsupervised learning helps in understanding data patterns. It helps in understanding data patterns and finding similarities or dissimilarities and identifying underlying structures, right? So these are the major characteristics of unsupervised learning, but it has more characteristics. Let's consider more characteristics. It's also used for dimensionality reduction, and then it's used for clustering. It's used for one common application is clustering, where the algorithm groups similar data points together, and this is common in customer segmentation or image segmentation. Uh, we we can see its use also in dimensionality reduction, and it's used to reduce the dimensionality of data, making it more manageable and preserving essential information. By dimensionality reduction, we mean when you have a data set that has many variables, let's say like 100, 1000 features. Not all those features will be useful for the model. You want to trim down the features. Maybe out of all those features, only 20 will be relevant for in the model for the target variable that can be used in supervised learning. Then you want to trim it down. Then you are talking of dimensionality reduction. Now we see some examples of unsupervised learning applications. We are seeing in clustering. When you use it, we use it. Organizations use it to group customers based on their purchasing behavior, and then dimensionality reduction. That is, like I've just explained, reducing the number of features in a data set for more efficient processing, and also uh, we see anomaly detection. That is, identifying outliers and rare events. You see, So that is very, very useful. And popular unsupervised machine learning models include k-mean clustering, hierarchical clustering. We have principal component analysis, and we have t-distributed stochastic neighbor embedding, and so on and so forth. Unsupervised techniques are available for data exploration mainly and uncovering insight in complex data sets, particularly when there is no prior knowledge of the data structure or pattern. Now, let's see this table that explains mainly the difference between supervised learning and unsupervised learning. I'm stressing this because it is very important. This is a very important foundation for you to know, right? So we'll see supervised learning as output response. In the supervised learning, output or response is known, whereas in unsupervised learning, the output label is unknown. Number two, supervised learning is mainly a predictive modeling technique for predicting future outcomes, or predicting or classifying future outcomes accurately. But unsupervised learning is a descriptive modeling technique used for explaining relationships among unlabeled data sets. Okay. Now, number three is unsupervised learning is used for classification and regression. And so we have classification and regression models. Okay. Now, in unsupervised learning, the major types of models are clustering and association algorithms. Supervised learning models have been said to be more accurate than unsupervised learning, and it is only in unsupervised learning that you see trainings, data splitting, data partition, training and testing. But in unsupervised learning, there's nothing like that. You don't train, you don't test, right? Now, the performance metrics in supervised learning are sensitivity, specificity, accuracy, ROC, curve, area under the curve, confusion matrix, and and others. Matthews correlation coefficient, balance accuracy, and so on and so forth. But in unsupervised learning, we use purity score, entropy, and others for validating results. Now, supervised learning has many algorithms. This support vector machine, random forest, k-nearest neighbor, naive Bayes, linear discriminant analysis, logistic regression, classification and regression tree, and so on and so forth. But unsupervised learning has lesser algorithm, e.g. k-means algorithm, hierarchical clustering, factor analysis, principal component analysis, and so on. Now, let's see this diagram. We're going to really talk about, especially in our lab sessions, we're going to talk about supervised learning and unsupervised learning. So this diagram explains the framework better. In unsupervised learning, we are talking of task-driven. It's task-driven. I mean, supervised learning is merely task-driven. The data is pre-categorized once, then it helps you to know the type of models to do, either classification or regression. And here are some examples. And then for unsupervised learning, the data is unlabeled. And then we have clustering, where you are looking at dividing the data by similarity. That is to do targeted marketing. Then association for customer recommendation, and dimensionality reduction, wider dependencies, which has wider dependencies, e.g. big data visualization. You know, association reduction, association models are used for customer recommendation. For instance, when a client you are doing online shopping, you are buying a trouser, and then a shirt comes up, and there's a suggestion of a suit. That is association. Customer recommendation, that is unsupervised machine learning at play there. It's recommending to you the things that the items that are likely to go along with your items. You get it? So now let's see reinforcement learning briefly. In reinforcement learning, we are talking about a type of machine learning that where an agent interacts with an environment and learns to make sequential decisions in order to maximize a cumulative reward. Now, it's different from supervised learning, where the model is trained on labeled data, or even unsupervised learning, where the goal is to uncover hidden patterns or associations. Reinforcement learning focuses on making just a series of decisions, trial by error decisions, in order to achieve a goal. Now, here are the key components of the reinforcement learning, right? Let's see the key components. Agents. There's always an agent who is the learner or decision maker that interacts with a particular environment, right? Then we see the external system which the agent interacts and from which the agent receives the feedbacks and rewards, right? Now we'll see the state, which is a representation of the entire environment at a given time.